My name is Yannis Atsonios. I am a mechanical engineer and I represent the National Technical University of Athens. NTUA is the project coordinator and responsible for the energy environmental assessment activities of PLUs and demo buildings. NTUA played a crucial role in the project as NTUA is the project coordinator under the leadership of Professor Maria Fundi and the leader of several technical activities. NTUA led the two work packages, the work package 1 and the work package 10, and overseen several tasks within work package 1, 2, 4, and nearly all tasks of work package 10. As project coordinator, NTUA was responsible for overall project management, while for the technical part of the project, NTUA was responsible for defining the key performance indicator, the established of requirements necessary for achieving in order to have a fast, low-cost, nearly zero-energy renovation for our demo cases for each country. And of course, additionally, NTUA collected all the necessary data that are available for all technical solutions to support the following project activities. Also, NTUA played a crucial role in the optimization and holistic assessment of PLU kits, conducting energy, seismic, thermal, fire, and environmental assessment, with a particular focus on the smart wall and the smart window. Furthermore, NTUA was responsible for energy, monitoring the life cycle assessment of demo buildings, especially for the Greek demo building and the virtual building in Berlin. NTUA successfully defined the objectives of the project from the early stages of the project, and of course, influenced the thinking of all partners to the common goal. The common goal was to create a fast, environmental friendly, and low-cost gem renovation. As the whole consortium includes manufacturers, architects, building owners, computer scientists, researchers, etc., NTUA achieved to bridge the gap among all these specialties. For the technical part, we defined and prioritized the renovation criteria in order to select the most appropriate solution using the modest tool that was developed by Indrasoft. Furthermore, through a holistic assessment of PLURAL solution, NTUA improved and optimized them in terms of energy efficient, comfort, fire safety, and environmental impact. Indicatively, the NTUA was responsible for the fire performance assessment of Smartwell. We tested via reaction to fire tests and SBI tests. So we proved a very good fire performance and we classified as PS1. Additionally, NTUA evaluated the energy performance of Greek demo building. The renovation of two apartments in a Vula building using the improved and optimized version of Smartwall achieved to reduce the energy consumption for heating and cooling by nearly 80%, resulting, of course, in nearly zero energy building. At the same time, the indoor thermal comfort conditions were significantly improved. Furthermore, an improved and the environmental friendly version of Smartwall was virtually implemented on Berlin demo case, and the results showed that we have a reduction of energy usage up to 85%. That means that it was about 20% better than the conventional solutions. Lastly, as project coordinator, NTUA successfully overcome the challenges that faced during the project, achieving the common goal to have fast and low cost energy renovation for all demos. For the PLURAL project, NTUA gained and expanded expertise in building physics, especially focusing on all-in-one prefabricated envelopes with integrated heating, cooling, and ventilation systems. So this project motivated us to deepen our research, conducting 2 PhDs and nearly 10 publications in journals and the national conferences. Concerning the technical part of the project, significant added value was the construction of a new pilot building at the campus of NTUA. During the project, we needed to test the PLURAL solutions, the smart wall and the smart window, under real conditions before installing them in the real demo buildings. To facilitate this, NTUA constructed a new building with easily removable walls and window systems. So two fully scale prototypes of a smart wall and smart window were produced and installed in this new pilot building, the living lab building of NTUA. The NTUA team then evaluated their actual performance with in situ measurements under real weather conditions. Another significant added value of NTUA was the development of multi-sensor. The challenge for us was to monitor the real thermal comfort condition in the Greek demo building before and after the renovation procedures. Since the apartments were occupied, we couldn't install a number of several sensor cables, data acquisition systems, etc. Instead, we developed a multi-sensor that combines all necessary measurements, meaning air and radiant temperature, relative humidity sensor, and air velocity. All these sensors were combined into a small box like a kit. So these devices send the data wirelessly via Wi-Fi to our server at NTUA, which collects and saves all needed information. Lastly, collaborating with experts from various European countries and different specialties allowed us to exchange knowledge and best practices. This helped us to develop and investigate innovative solutions that might have not explored without the PLURAL. Additionally, the partnerships we formed through the project created a strong network that we can collaborate for future projects. Regarding the lesson learned in the PLURAL project, NTUA learned valuable lessons. I think one of the most important lessons for me is the collaboration with several European partners and experts such as manufacturers, computer scientists, architects, and designers. This collaboration taught us the importance for clear communication and understanding the different varied perspectives. Regarding the challenges for the technical part of the project, a significant challenge we faced was convincing the occupants of Vula Demo building to adopt new and innovative technologies in their home and trust that our renovation procedure will be fast without severe disruptions. So we succeeded, encouraging them by explaining that the renovated homes will have better comfort conditions and, of course, low energy costs. Another, of course, challenge was the development of multi-sensors that I previously mentioned. And another challenge was how to investigate these complex and hybrid fabricated facades. All these prefabricated facades includes both active and passive system and also automation control systems. This means that it is highlighted the need to use dedicated assessment tools because all available standard energy tools couldn't account for these complex systems and their interactions. For this reason, we used advanced software like Transit and Console to evaluate all PLURAL solutions under real conditions. And of course, one challenge that every project in this period faced was the COVID-19 situation, which began shortly after the proposal submission in February 2020. So we managed to adapt this issue by organizing regular virtual meetings. Yes, in the future, the NTUA team plans to use this simulation and monitoring data for further research. We have to analyze the results in more detail, focusing on the further optimization of smart goal in terms of energy and environmental impact, and we are going to convert this smart goal with other innovative prefabricated solution. Of course, we will continue to improve the smart core using eco-friendly materials and adding more functionalities. And one other works that we are planning is the further development of multi-sensor. We want to add new sensor and features such as some user-friendly smartphone application or the integration of multi-sensor into the building management system.
Hello, I'm Diana Romeu. I'm a civil engineer from ITEC, Institute of Construction of Catalonia. I'm working in the Sustainable Construction Department. As ITEC, we have different roles in this project. The main ones has to be in charge of the calculations of the impact of the 3 new kits, and also the support of the definition of the digital standard for the life cycle assessment. But also we have in charge of the preparation of the certification process, not a certification process, just a virtual process for the preparation in the future of these certification new products. Also we have in charge of the modeling of the 3 kits, and now we are preparing the best practice certification handbook. So we have completed the life cycle assessment, the life cycle cost of the 3 different kits, and not just one kit from each one, not 101 configurations of all the kits. That means that in some of them, maybe we changed the double glassing to triple glassing. We changed the frame for a different material from the windows. We have different thickness for the insulation, for example, and we have evaluated all of them. We also have working about the social assessment. We have evaluated the kits using the standard EN 16309 with help of other partners. This standard views all the building, and we have first checked that we have to review the impacts that applies only for the kits, but the work has been done. We also now we are working on the digitalization process. Have reviewed different regulations, the actual BIM files, IFC file, the actual EDCA standard, in order to propose a new standardization that we have called it ITEC standard, and that it's based on a matrix that combines different phases and the different types of elements that you can find in a project. Okay, as responsible of the sustainable and part on the digital standardization, we have created a new methodology that we haven't used it before, that link all the BIM modeling of whatever you have, an element, a kit, or including a building, with the life cycle assessment, the life cycle cost, and that establish a new way to execute the digital process in order to complete the LSC assessment. So that will be used in the future project that will be involved. The main lesson is that here we have to evaluate it in the new product under the development of this product. So we had this a challenge because the final design of all the kits and all the configurations, we haven't had it till the end of the project. So it was very challenging, and we have tried to work closely with designers and the developers in order to succeed in this task. Okay, as I explained, we are working on the new standard for the LSC assessment, and that have to do more work on that. So we will try to develop in deeply this proposed of the standardization, this ITEC standard, and also we were in charge of the exploitable result of the best practice handbooks. They will be on the PLURAL website, but as well in our website. So we will in charge of to have these handbooks available for everyone. There will be 3 handbooks for certification, industrialization, and renovation. Working in a project like that, it's normally difficult because you work with a lot of partners. In this case, 18, if I don't remember badly. But I think after the years and the work closely together, we have established a good communication, because I think it's the key in every European project, because we are all people from different countries with different language. We try to establish a common purpose to have the goals of the project. So for me, it has been very challenging to work this way, but I have learned a lot of things, to work with different people, to think differently in some types of parts of the project, that maybe you have another point of view that helps you to work in another way. So I am very happy to work in this kind of projects.
So my name is Angelos Milonas. I represent IREC, the Institute of Energy Research of Catalonia, which I'm currently working in the group of thermal energy and building performance. Well, as IREC, we are the leading partners of Work Package 3, which is about the smart control of the PNU components. This involves the development of control algorithms in order to improve the efficiency of building systems and increase the energy savings. Such systems could be, for example, the ventilation unit, the heat pump, the heating and cooling, the active heating and cooling components, etc. Also, IREC has a leading role in the monitoring campaign conducted in the 3 demo sites in the Voulavari Vouliagmeni, Terrassa and Kassava. So within Work Package 3, the first achievement was related to the fault detection and diagnostic algorithms. We utilized data-driven algorithms in order to be able to detect and identify issues related in the PNU kits. Most of these issues refer to the erratic behavior of the PNU components, and in particular the ones that are met in the HVAC units, such as the ventilation, the heat pump, and the active and heating and cooling components. Such errors are responsible and cause the decreasing of the efficiency and the underperformance of such devices. Consequently, this leads to an increase in the energy usage, and sometimes they are unable to reach the indoor environment quality conditions and the preferences of the users. The role of our algorithms is to detect an operation drift and send a warning signal to the user so that the error is checked and then consequently fixed. We also developed a set of predictive algorithms for optimal building energy management. These algorithms, very fast, within a matter of few seconds in fact, and based on a set of criteria defined by the user, can provide the optimal energy strategy. These criteria depend and are defined by the user. This can be, for example, the minimization of greenhouse gas emissions, the maximization of the energy savings, or the energy cost minimization. In order for these algorithms to operate effectively and properly, the user needs to define a set of inputs, which can be, for example, the building geometry and thermal characteristics, the occupants' desires and indoor environment quality conditions, and their preferences in general, the weather conditions, the energy price, and many others. And they can provide results in a horizon between 24 and 72 hours for the optimal control strategy. All this development was based on the model predictive control methodology, which according to literature is identified as one of the most efficient control strategies for the energy optimization and indoor environment quality of a building. Lastly, a milestone achieved in Work Package 3 was the remote implementation of these model predictive control methodologies utilizing the LYSIS platform. In collaboration with Intra, we set up this platform, and we effectively manage the energy performance and the indoor environment quality of the Bern virtual demo site. The big advantage of this implementation is that no additional hardware is needed. It was done in a remote way using the existing control infrastructure of this building, which means reduced costs. So during PLURAL, we were given the opportunity to deepen our knowledge in some tasks, as for example, the smart energy management system and the fall detection algorithms. That is something we've been working on over the last few years. At the same time, we are given the opportunity to work on some tasks we're not familiar with, such as the monitoring for assessment task and the task on the environmental cost and social impact assessment of the PNU kits. This definitely gave some value added to our group and also increased our field of knowledge. In terms of lessons learned, I think the most important was the effective communication, especially when we were working on complex tasks. That collaboration between several partners is imperative. Meetings regularly were required in order to exchange information and update each other on the current developments, because some topics were interfering with each other, so it was necessary to have an effective way to communicate the changes and updates. In terms of challenges, the first, on the technical level, the most important challenge was related to the remote implementation of the model predictive control algorithms, and this was something outside our field of knowledge. And after a lot of research and collaboration with Intra, we managed to overcome it. The second one is related to the data management from the real demo site. Before the beginning of this task, this knowledge was not available on our group. However, it was only available on a theoretical, let's say, or computational level. Now, within PLURAL and within this task for monitoring, we managed to overcome it. So in terms of that, we will of course evolve some of the existing algorithms, especially on these topics, smart energy management and the fall detection. We are trying to disseminate our work either on conferences or scientific journals, and future collaborations will show the way also.